A random sample of n observations is selected from a population with a standard deviation of sigma equals 36. Calculate the standard error of the mean SE for each value of n. All this is really asking us to do is use the formula. The standard error of the mean sigma sub x bar equals the original standard deviation sigma divided by the root of n. So for each of these, we're going to use 36 as our sigma. That means that here sigma sub x bar equals 36 divided by the root of 100. If I put that in my calculator, it's really going to become 36 divided by 10, which is 3.6. For part B, sigma sub x bar equals 36 over the root of 4. The root of 4 is 2. 36 over 2 gives me 18. For part C, sigma sub x bar equals 36 over the root of 81. Root of 81 is 9, so this becomes 36 over 9, which is 4. For part D, we get to one that I can't do in my head. So here, sigma sub x bar equals 36 over root 44, but root 44 isn't a perfect square. So if I put it into my calculator, 36 divided by the square root of 44, my calculator tells me that that's equal to 5.427, which I'm going to call 5.43. Same idea here. I don't know what the root of 17 is, so sigma sub x bar becomes 36 over the root of 17. When I put that into my calculator, I get an answer of 8.73. For questions 8 and 9, these are just word problems where I have to pull out 3 key pieces of information. I need to know what the mean is, I need to know what the standard deviation is, I need to know what the sample size is, n. So this first one, number 8, says a study of newborns found that they first learned to walk after an average of 350 days with a standard deviation of 30 days. From that, I need to pull out that the mean of the distribution, or mu, is going to be 350 because that was the average. The standard deviation, or sigma, is going to be 30 because that was told to me as the standard deviation. If 36 newborns are going to be sampled, we now know how many there are. That how many is an n, or a sample size. Now that I have this information, the easy part is the mean of the sampling distribution. All I do is copy whatever the mean was of the original distribution. The slightly trickier part, the standard error, I'm going to take the standard deviation I was given, 30, I'm going to divide it by the root of n, in this case the root of 36. So this is going to become 30 over 6, which means sigma sub x bar is 5. For number 9, same idea. I'm going to read it and pull out the information I need. We see that the full-grown pugs have a mean weight of 25 pounds. That's going to be my mu, the population mean. They have a standard deviation of 4 pounds. That's my sigma, 4. And we're looking at 75 pugs. That's my n. Again, as far as the mean of the sampling distribution, mu sub x bar, that just is exactly the same as the mean of the original distribution. For sigma sub x bar, here I should be taking the 4 that was the standard deviation originally and dividing it by the root of n, in this case the root of 75. Again, that's not a perfect square, so I'm going to need my calculator to do it for me. 4 divided by the root of 75 gives me 0.4618. I'm going to call it 0.46.